Alrighty, in this video we're going to start taking a look at more ways to work with our component map. In particular, we do need some sort of mechanism for given a type returning an ID. Meaning, if I map a component to have a particular ID, I need to be able to retrieve that ID given a particular type. So to do that, it should just be a matter of adding a new dictionary to our component map class and then populating it as we map components. So the first thing I'm going to do is write a test for it. So I'm going to go ahead and say test, and then I'm going to say public void something like can get mapped component via type. And just like how I did with the first one, I'm going to do this with test cases. So I'm going to say component type byte component ID. And then I'm just going to really just copy and paste all of these test cases that I have already written. I'm pretty happy with byte min value, byte max value, some arbitrary byte value, and 1 being the IDs that we test all our stuff against. So now let's go ahead and arrange. So I'm going to say component map equals new component map. Then we'll have to act on it. And so to act on it, I simply do component map dot map component, passing in the component type as well as the component ID that are provided as parameters to this test case. And now we have to go ahead and assert. So what's the assertion going to be? Well, I want to be able to invoke a method and have that method return to me a component or a mapped component object that is of the correct type and ID of what I had mapped that component to, which will necessitate creating an additional method on our component map. So I'm going to say var.mappedComponent equals component map dot get component by type, which is just an arbitrary name that I've decided. Alternatively, I could just say get component and then let the fact that the method signature will accept a system.type to indicate that that's how we're getting the component. Then I'm going to say component type. Now I need to ensure that this mapped component is not null, so should not be null. I need to ensure that the mapped component dot type should be component type. And I also need to ensure that the mapped component dot ID should be component ID. And that's really all I need for this test. I'm just implementing one new method called getComponent, which should return this behavior. So I'm going to go ahead and move our test off to the side so we can watch the test and watch our code at the same time. I notice my syntax highlighting is messing up. I might just have to go ahead and nuke my ReSharper cache. But anyway, let's go ahead and introduce that method. I'm going to say public mapped component get component type component type. So what's this method going to, how is this method going to work? Well, we see that we don't actually have enough information. Now we could certainly loop over our mapped component array. I don't want to do that though, because that would be very inefficient. That would give us a ON lookup time basically, and it wouldn't be the most efficient way to get a mapped component from a particular type. A more efficient solution would be to use a dictionary, but that would require that we would have to populate that dictionary as we map components. So what I'm going to do is up at the top, I'm going to say private read-only dictionary, which will import system collections generic. It's going to be of type type and mapped component, and I'm going to call this dictionary types to components. Now I must initialize this dictionary, so I'm going to go into my constructor and I'm going to say types to components equals new dictionary of type and mapped component, like that. And then my getComponent method, I will simply return types to components at component type. Now again, I'm not worried about the exception that would be thrown if this key doesn't exist. I would consider that to be a feature because I don't have to add any additional error checking, because it'll just return and throw an exception which will be caught and logged and the entire request will be halted, which is exactly the behavior that we would want in the case of an invalid type being used, because that would indicate a bug in our code. Remember, exceptions are your friends. Don't try to eat them. Okay, so this code actually won't work, but I will go ahead and run it because now our code is finally at a compilable stage. So I want to go ahead and run the test to show you guys that it's going to fail. So let's go ahead and up here and hit run to run all of our tests. Since we have so few tests, I'm mostly going to just run all of them every time we run a test. When we start getting way more tests, then we can start selectively saying, okay, well, these tests I won't run because I don't want to deal with it right now, don't want to deal with the performance. But with so few tests, we can just run all of them all the time. So now we see we do get all 4 error cases throwing, and they say key not found exception, which is great because that's the behavior that we were expecting. If this test succeeded, we had clearly done something wrong, or I just don't know how to write C#. Okay, so on the map component method, all we simply have to do is add a new element to this dictionary. So I'm going to say types to components dot add component type and component ID. Or whoops, component type and component. Okay, so this will add this particular mapped component to the dictionary so we can retrieve it. A couple important things to note. First of all, in the design of the component map, I will not consider ever the ability to remove a mapped component. Components are write-only in my opinion, just the way that I think it should work. So we're not having to worry about cleaning up any of the things that we add for caching. Second of all, I am not concerned about performance of the map component method. Now, right now it looks pretty innocuous, but in the future, once we get into dynamic code compilation, there will be some more heavy lifting going on. However, since there are only ever going to be 2 mapped component maps in each client and 2 component maps in each server, I find it irrelevant to consider the time it takes to start create a component, because this is not going to be something ran every frame. It's only going to be ran at startup. Finally, there's actually something really subtle I just put in here, which I just want to outline for people who might not be familiar with this. You might be asking, why didn't, instead of doing this, types to components dot add component type component, why didn't I just do types to components component type equals component? Well, it's a very subtle difference that has far-reaching implications. Basically, the difference between these two is that this one will throw an exception if a key already exists in the dictionary, meaning this line will throw an exception. It'll halt execution if we are trying to map the same component twice, which actually gives us a little bit of added functionality without having to write any additional code. Now we can be protected against mapping the same component twice. In fact, we could also go ahead and write a test case for this behavior as well, which I think I'll do to ensure that this behavior is solid and won't change as we modify the code. So this one will not throw an exception if we already have a component mapped. Second of all, the important aspect to this, another important aspect, another subtle difference to this, is you'll notice the order is significant. I do this adding before I set this array index. Why? Well, if this throws an exception, I don't want to leave this method in an invalid state. Up until this point, this method you could consider this method pure. It doesn't actually do anything. Well, rather, up to this point, it doesn't actually do anything that would affect the state of the component map, meaning we can terminate early from this method at this particular point without having any invalid state in our object. But once we get down to this, we now have a side effect that affects the object. So I want any code that could potentially throw an exception, or at least to the extent that I can do this, I want that code to be before the point in which the state of the object is modified to prevent the possibility of the object becoming in an invalid state. So this is another important, rather subtle thing that has actually far-reaching implications. A lot of bugs that you see in software is caused by errors that happen, but that happen in particular ways that result in an invalid state. By adding the code that can throw to before changing state of the object, it guarantees that this method or this object should not become invalid. Anyway, so there's two little subtle things. Let's go ahead and rerun all of our tests. And we get success. Now let's go ahead and write another test really fast to ensure that this behavior is enforced. Now, that was actually a very careful choice of words I just used. We should always write tests when we're doing this and it's convenient that ensure that the behavior of an object will not change over time. You'll notice that these tests that I've already written, I'm still running them. And I'm still running them because I modified this method. Imagine if I modified this method in such a way that it broke it. I wouldn't know it if I wasn't running the other tests that also tested that same bit of logic. Okay, so let's go ahead and write that test to make sure that we can't add two different components that are the same type. So I'm going to say public void mapping to components with same type throws exception. So let's arrange component map equals new component map. Then let's act component map dot map component type of iComponent, iTest component. Let's move this over here so we can see that a little bit better. Let's do an ID of 1, and then let's go ahead and create our action delegate. Which is going to be component map dot map component type of iTest component 2. We'll make sure to use different IDs because we're not testing the fact that it throws when we use the same IDs. Then I'm going to say fail condition dot should throw, and I'm just going to say exception. I don't really care about the type here of the exception. It can throw any type of exception for all I care. So I'm not too worried about that. As long as it throws an exception, I'm happy. So now let's go ahead and hit run all, and we get success. Let's go ahead and make sure that we run all of our tests here. And we do. And we get, oh, as you can see, we didn't actually get that test added to our session. If you ever notice that you're not getting a test added to a session, it's probably because you forgot, like I did, to add the handy little test attribute above that method. So now that I've done that, it's considered to be a test, and now it shows up in my queue. So let's hit run all, and we get success. Let's make sure this test actually works by commenting out that one line right there that throws. You guys don't have to do this, but I just want to be absolutely certain. And then I'm just going to run this one test here. And I should get an error. I get an error that an error didn't happen, which is what I want. So now re-uncomment that out and run again. And we'll see success. So yeah, that's the ability of mapping in that fashion, or at least retrieving data from the type of the component. Another interesting thing that people might not be aware of that I want to illustrate is the fact that I can't use implicit typing on either of these local variables. You'll notice that I am a huge fan of implicit typing, and I use it everywhere that I can. So you might be wondering, well, why are you explicitly specifying the type of that local variable where everywhere else you use var? Well, if you've already tried to use var here, you'll see that it throws an error. So you watch what happens when I do type in var right here. I get an error because you can't actually assign a lambda expression to an implicitly typed local variable. The reason for that is the lambda expression isn't actually a typed thing. This is what I have selected right here doesn't actually have a real type to it. We need to provide the type information to the compiler rather than the compiler knowing the type information itself. The reason for that is in .NET you can create a variety of delegate types. So I can create a delegate type called, like I can just show you right here. I can say public delegate void ble1, public delegate void ble2. Now what's interesting about these two delegates is that they're both void and they're both parameterless. So they have the exact same signature, but they're two distinct delegates. They're two distinct delegate types that are incompatible because they're different types, and this is a type language, and you can't assign one type to another. So the type of the delegate is important, not just its signature. And that means now that I have these two delegates right here, how would C# know whether to fill this implicit typing, if it were implicit typed, with action, ble1, or ble2? It wouldn't, because all of them would fit, because all of them match this particular signature of this lambda. And the signature of this lambda is that it returns nothing and that it takes no parameters. So we actually have to provide to the compiler explicit typing for using lambdas, and this is that's how the type system works. The same principle happens when we assign method groups to parameters as well, or to local variables. Anyway, so yeah, that was just a quick aside, and I think that pretty much wraps up what I want to do. Pretty straightforward, not a whole lot to it, but some really important concepts as far as where we place our code and what type of code to write. And the fact that you should never be afraid of exceptions. So we'll see you guys in the next video.